Hi friends, today we're going to learn decision trees, right? So name itself is called decision trees. Two terms are involved, decision trees. It means based on the decision you're going to create or draw or construct the trees, right? Why decision trees is required and when to apply this. So some problems are called as a NP hard problems, right, or computationally hard problems. So those kind of problems even solve using decision trees, make decision at each and every steps, right? So maybe after making the decision we'll be going and reaching to the nearby the answer, approximate or exact, but we can make a decision at each and every level such a way that we can achieve or we can get a solutions for the given problems. So decision tree is for finding minimum of 3 numbers or maximum of 3 numbers. We can make a decision. Decision trees for the tree element selection sort. Decision trees for 3 element insertion sort, right? It is 3 element selection sort. Decision trees for 3 element insertion sort. Decision trees for searching or sorted array. So fourth one is what? We are going to search some elements in the given sorted elements. So we are going to make a decision, right, based on the given conditions. So either condition will be true or condition will be false. So we are going to follow the both the paths. If it is condition is true, what is going to happen? What will be the outcomes? If condition is false, which kind of outcomes you are going to get it? So here we have internal node comparisons, leaf representations as a outcomes. It means all the outcomes will be there at the leaf node. All the outcomes will be there at the leaf node. While internal node is used for comparisons. It means what? We are going to make a decision on each and every internal node. And decision will be only two cases, either yes or no, true or false. We are going to make a decision based on the given conditions. Driving a lower bound from the decision trees. How does a tree help to find lower bound? There must be at least one leaf for each correct output. If you are saying at least one leaf, it means what? We are getting one outcomes out of that conditions for sure. And tree must be tall enough to have that many leaves. When you are saying that tree is enough to have many leaves, it means what? Many outcomes, right? Banded trees with L leaves and H height. L leaves and H height, right? So remember that as height of the trees we have discussed and we are knowing that height of the binary tree is going to be log n base 2, right? If it is full banded trees. If it is the ordinary banded trees, it is going to be more than log n base 2. If it is not a full banded trees, any other banded trees greater than log n base 2. Otherwise it will be log n base 2. Now, height of the banded trees, there is a relations between height of the banded trees and number of node in the banded trees, right? Similarly, we can find out relations between internal node as well as external node. So some of the algorithms, as I shown you before, some of the algorithms depends on the number of leaf node you are going to generate, and it computes the time complexity based on the number of leaf node. It means what? Number of outcomes, right? We are going to write the time complexity. In some cases we are going to see that how many number of comparisons you have done to get such and such leaf node, right? So both the way we are going to follow, right? We are going to find compute the time complexity. So let us see that first examples. Now I wanted to tell you that here L is represented for leaf node and H is represented for height of the trees. Let us see that. First, to find minimum of 3 number. To find the minimum of 3 number. So say we are having the values A, B, C. How are you going to compare? First, I'm going to say that if A is lesser than B, right, and condition is true, it means what? A is lesser than B. Otherwise, if you are going in other side, it means what? B is greater than A. A is lesser than B is not there, it means what? B is greater than A. So if it is true, we coming to these directions. And again, you are going to check that if A is greater than, A is lesser than C. So here you are saying that A is less than B, here you are saying that A is lesser than C. So A is lesser than B also, A is lesser than C also. So who is lesser? A is lesser. So we call it as A is a small in this case, right? If not, it means what you are going to write? C is lesser than A. Now let us see that A is lesser than B. We can compute here. A is lesser than B, and we are saying that C is lesser than A. A is less than B and C is less than A. Who is the smallest? C is the smallest. If you are going to combine this, C is the smallest. So C is small here. Similarly, if this condition is false, then B is greater than A. B is greater than A, and you are saying that B is less than C. So we can write this. Okay. A is less than B is not there. It means what? A is greater than B. Right? A is greater than B. Or you can write it in another way. B is less than A. Right? Reverse of this. So what will happen? Or you can put equal to sign. It is up to you. So A is less than B. B less than A. B less than A. And here you are saying that B is less than C. B is less than A, B is less than C. Who is lesser? B is lesser. So you make the decision, B is small. If not, then who is lesser? C is less than B. Ulta. C is less than B. So you are saying that B is less than A, C is less than B. We are going to combine this. Who is lesser? C is lesser. Just to combine, B is less than A, C is less than B. Right? So overall, C is small. So this decision you make it out based on the comparisons. We have done the comparisons on each and every levels, and we got the leaf node as A is small, C is small, B is small, and C is small. Right? So how many leaf node you have? 1, 2, 3, 4. So you are going to write log 4 base 2. Log 4 base 2. Right? So it is 2. It is 2. So we see that we are having that height of the tree. We are going to say that it will be h is equal to or lesser than equal to log L base 2. So it is 2. So we will consider height from 0, 0, 1, 2. Right? And leaf node, all these leaf node are there in the same level. It's not mandatory that all the leaf node will be at the same level. So this is all about how to find the minimum values. It is very simple. Just to go and compare, right, and make your decision, and that decision will be marked as a leaf node. External node will be considered as a decided results. Now decision for 3 element selection sort, right? So how it will go? Again, you are going to perform selection sort. Remember that what you have learned, that we are going to find the minimum element and finding the appropriate place, swapping with the very first element. That is the position of the minimum element. If there is element A and C and B has to be, we are going to swap such a way that B will be like A, greater than A but lesser than C. Right? So we are going to swap the elements and we are going to present at the A is less than B, less than C kind of things. So with these examples, you are going to find how we are going to perform for the selection sort, right, based on these 3 elements. Let us see that in ABC, if A is lesser than B, you already make the decision A is less than B. Now, here saying that A is less than C. So one thing is confirmed, A is lesser than B and C. Right? So based on this, all of you please concentrate. A is less than B, A is less than C. So A is less than B, A is less than C. One thing is very clear that A is lesser than B and lesser than C. But we don't know that what will be the order of B and C. What will be the order of B and C, right? Whether B is lesser than C or C is lesser than B. That is not yet clear. So, you have to check one more conditions for B and C, right? So, here we are going to check B is lesser than C, true. It means what? A is less than B and B is less than C, hence A less than B less than C. So, we made the decision. If not, it means what? C is less than B. If C is less than B, it means what? A is less than B and C is less than B. So, A is less than C less than B. We made the decision. So, we got these two outcomes based on three comparisons over here. Similarly, if it is not true, then it means what? C is less than A. A is less than B. C is less than A. If you are going to combine this, it means what? C less than A less than B. C less than A less than B. Just to combine it, C less than A less than B. Means this is the third conditions. So what we have done? Just we made one comparisons. Right? Similarly, now let us see that in this particular case, else part. Else part, what will happen? B is less than A. No, B is less than C. So one thing is very clear, B is lesser than A and C, but we have to check one more conditions for A and C. So we are checking that if A is less than C, then B is less than A less than C. Otherwise, B less than C less than A. Similarly, for the right hand side, you are going to get it C less than B less than A. So this is basically, we are having how many outcomes? 6 leaf node. 6 leaf node, right? And these all comes, how many leaf node got? 6. Why it is 6? Because how many number of nodes we are talking about? Number of values are 3. A, B, C. How many elements? 3 elements. So 6 outcomes you are getting. 6 leaf node you are getting. So 3 factorial is going to be 6. 3 factorial is going to be 6. So here we are saying that C worst is going to be greater than equal to log n factorial base 2. So what is log n factorial? Log 6 base 2. It is be ceiling function. It is not a square bracket. It's going to be ceiling functions. So answers is going to be 3. 1, 2, 3. Right? So height is 3. 1, 2, 3. So computational values will be ceiling functions. Log 6 base 2. As in previous case also, I said that it should be lesser than this. So it is log 1, 2, 3, 4 base 2. Right? Log 4 base 2. So let us see that what will happen when we are talking about insertion sort for the decision trees. So again, based on the 3 elements, we are going to perform A less than B. Insertion sort, you know that element to be inserted at their right positions. That is called insertion sort, right? So based on the comparisons, we are going to decide this particular element will be inserted at their right position. It is the smallest one, will come at the beginning. It is largest one, go at the last. It is in between values, it will come between first and last if there are 3 elements. So A is less than B is true. Here we are saying that B is less than C. A less than B, B less than C, decision is made. A less than B less than C. If not, then it means what? C less than B. Look, A less than B, C less than B. It is decided that A and C both are lesser than B. A and C both are lesser than B. It means B is the largest one. Now we have to decide between A and C. So if A is less than C, then we can make a decision A less than C less than B. Otherwise, C less than A less than B. Similarly, right hand side, it is going to be B less than A. If no, A is not less than B, means B less than A. If B is less than A, and here talking about A less than C. So B less than A less than C. It means B less than A less than C. Similarly, in right hand side, if condition is false, then C less than A. B less than A, C less than A. So this part is clear that B and C both are lesser than A, but we don't know that among B and C, right, whether B is lesser or C is lesser. So you have to check one more conditions. So if among B and C, if condition is true, B less than C less than A, otherwise C less than B less than A. So this is basically based on the insertion sort. Again, you are going to say average complexity is going to be log n factorial divided by 2, where n is a number of elements present for insertion sort. So 3 factorial is nothing but 6. Now decision tree for searching of sorted array. But for examinations, they will ask maximum of 2 questions in one decision tree. But it is very simple. Only we have to practice for the comparisons and how to represent in the form of leaf node, right? And represent leaf node in a square bracket at the last. Now, searching of the elements. When you are searching of the elements, there will be 3 scenarios. If element is equal, or element is lesser than, or key element is greater than the values. 3 scenarios, right? So, based on that, 3 outcomes, we are going to represent this decision trees. So, let us see that if you are going to compare A of 1. So, what will happen? Maybe the key element is equal. We say that this is your leaf node, means you made your outcomes over here. We made your decision over here that element is found, A of 1. If not, say key is lesser than A of 1, it will go in the left hand side. You go in the left hand side. Maybe positions will be A of 0. If element is found, it is of A of 0. If not, element is going to be lesser than A of 0. Otherwise, if element is not equal, not lesser, then it is going to be between A of 0 to A of 1. Greater than A of 0, lesser than A of 1. So, between the range of A of 0 to A of 1. So, last decision is element is greater than A of 0, but lesser than A of 1. So, it is as simple as it is. Element is lesser than A of 1, lesser than this, greater than this, right? So, that will be the key element, must be greater than A of 0 and lesser than A of I. So, basically this symbols will be ulta. Okay. So, next is, say if element is greater than A of 1. If element is greater than A of 1, it will go in right hand side, right? Then you are going to compare. If A of 2 is the same elements, what you are searching for? Key element. Then element is found. Otherwise, it go, oh, element is lesser than A of 2 and greater than A of 1. What is that symbol? Greater than A of 1. Lesser than A of 2. So, this is the results when you can say that key element is greater than these values and lesser than A of 2. Okay. So, you can represent as A of 1 is lesser than key element and lesser than A of 2. So, this can be represented like this. As you represented earlier, A of 1, key element is greater than A of 1 but lesser than A of 2. Similarly, if it is greater, we will go to the A of 3. If key element is same as A of 3, key element is found. Otherwise, left hand side of A of 3 means what? Greater than A of 2, lesser than this. So, greater than A of 2, it means what? Again, you are going to write it A of 2 less than key element less than A of 3, like this, right? So, this is for A of 2, between A of 2. This is a short representation, A of 2 to A of 3. It means what? Element is between A of 2 to A of 3. And here element is greater than A of 3. So, whatever the elements will be, that will be greater than A of 3. So, this is basically, we have many outcomes, right, based on the number of comparisons and each and every steps, right? So how many number of elements was in this? A of 0, A of 1, A of 2, A of 3, right? There are 4 elements we have represented over here is, right? So we are going to say that log 3, 2n plus 1, n is nothing but A of 0, A of 1, A of 2, A of 3, 4, 2 4 ja 8, plus 1 9. So log 9 base 3, right? Because why 3? Because in each and every steps, each and every conditions, we have a 3 outcomes, right? It is not binary decision, it is ternary decision, right? Hence it is log 3. So log 9 base 3, so 3 square. So we are going to make this decision, right, more than 2. So C worst will be greater than equal to 2. C worst will be greater than equal to 2. If you are going to simplify this, again you have to write this as ceiling function. Values will be greater than the given values. So alright, decision trees we have to apply for computationally hard problems to make a decision based on the given conditions, right? And we have to solve for the both the cases where condition is true or condition is false. Just represent your decision at the leaf node. So leaf node is going to be the outcomes of that decision trees, right? And this is represented in the binary form or ternary form, depends on the outcomes, right? When you are talking about finding the smallest element or largest element, selection sort or insertion sort, these are the binary decisions, right? But when we are talking about the searching of elements, here we have 3 outcomes. Maybe key elements are going to be equal, key elements are going to be lesser than the values, key elements are going to be the larger than the given values. So we have to discuss based on the all 3 different scenarios, right? Thank you very much.